All right, so today we're going to be talking about theoretical and experimental probability. So, theoretical probability is the equal likelihood of something happening in a perfect world. So, essentially, what I'm saying is that if I were to flip a coin and it landed on tails, then theoretically it should land on heads the next time. Experimentally is when I actually do flip that coin and it ends up landing tails, tails. Or it did end up landing tails, heads, or heads, heads. Who knows? So experimental means you actually did it, you performed that probability or test. And theoretically, it's like perfect world, it lands on heads, so the next time it will land on tails. All right, so here we go. Playing a game of rock, paper, scissors. Theoretically, I should win every third time, according to my chart. Because if I do rock, rock, the next time I should do paper, and then my friend should do paper and I should do rock, and then the last time if I continue doing rock they should put scissors and I will win that third time. So looking at this chart, A wins 3 times, which would mean that that is 1/3 of the times, or 3/9, just reducing it. Same thing for player B, wins 3 out of every 9 times played, so that will give me 1/3, and there are 3 ties. So I had my stepdaughters play rock, paper, scissors. And so when they did that, player A won 10 times, player B won 7 times, and there were 8 ties. That being said, we know what percent of the trials did partner A win? Well, there were 10 that they won out of 25. So I divide that by 5 and I end up getting 2/5. For percentage B, I have 7 out of 25. And for ties, I have 8 out of 25. So now when I'm looking at 7 and 8, it says, do the theoretical results match the experimental? No, not exactly, because 1/3 is about 33%. And 4, when we look at question 4, 2/5 is about 40%. So is it close? Yes. If we look at 7/25, that's about 28%, so it's close. And for 8 out of 25, that's about 32%, which is probably the closest for ties. But really, the more often, the answer to question 8, the more often you do it experimentally, the closer you should be to theoretical. Okay, so this is kind of like playing the lottery or gambling. It says usually 1 in 3.97 chances of winning on a scratch-off ticket. Well, that means 1 in every 4, theoretically. So if you bought 4, you should win once. That doesn't always happen, though. All right, so here we go. We're looking at this table for number 9. So number 9, we rolled a die 50 times. So a die has the numbers 1 through 6 on them. So when we're looking at this, we see what is the theoretical probability of rolling a 4. Well, theoretical means a perfect world. So theoretically, every time I roll it, I have 1 chance to get 4 out of 6 chances. So 1/6. If I look at the experimental, which is this chart to the left, I notice that 5 out of the 50 times it landed on the 4. So I divide this by 5 and I get about 1/10. Now 1/10 is actually smaller than 1/6. So it's a little bit smaller, the experimental, than the theoretical. But if I did it more times, I would probably get closer to it as well. Oops, I did not mean to delete. I meant to circle. There we go. All right, so here we're going to look at the spinner at the left for number 10A. It says, what is the theoretical probability of landing on a shaded letter? Well, there are 8 letters, and I have 1, 2, 3, 4, 5, 6. 6 out of 8 letters are shaded. So if I divide by 2, I get 3/4, or about 75%, 0.75. Okay, now when I look at the 75 times that they ran this through, experimentally landing on a shaded letter A, B, C. So if I add those up, I get 22, 27. This is 27. And then if I add up E, F, and G, these 3 here, that is 24 plus 9 is 33. If I add those together, I get 50. No, not 50, 60. There we go, 60. So if I divide this by 5, I end up getting 12 over 15, and I can divide again by 3. So that ends up giving me 4 over 5, which is about 80%. So when I look back at letter A, that was about 75%, and letter B is about 80%. That means that they are close. We did it 75 times this time instead of 50 like we did in number 9, and we're getting closer to the theoretical probability. All right, here we go with number 11. Number 11 says, theoretically, how many times would heads expect to land when you flip a coin 300 times? Well, theoretically, it should land half of the times, 150 out of 300. Okay, because it should be heads, tails, heads, tails, heads, tails the whole time. Now, based on that, we see over here that it landed 100. They flipped it 100 times, and it landed on heads 58 out of 100. Now, we want to know how many in 300 chances. So we're going to have to multiply both the top and bottom to get an equivalent fraction. So we have 300. And then 58 times 3. 8 times 3 is 24. 3, 15, 16, 17, 18. 184. So 184 300ths is close to our 150 300ths. Not exactly, but a little bit more landing on heads than tails if we use that information. All right, here is our last one that we're going to do. So last one, number 12, it says, theoretically, if a letter randomly selected 500 times, how many vowels would you expect? So we look at rhombus, and we have 1, 2, 3, 4, 5, 6, 7. We have 7 letters, and out of those, we have 1, 2 vowels. Okay, so vowels are A, E, I, O, and U. So out of that, we need to figure out how many out of 500 times would that be. So we have to create a proportion to figure this out. So we're going to cross multiply, so we get 7x equals 1,000. And we're going to divide by 7 on both sides. So x is equal to, I'm going to have to pull up my calculator. Sorry about that. So 1,000 divided by 7, 142, so about 143 times. So my answer for this question is 143 out of 500. And then over here, for part B, it says, what about the experiment? So I see that O and U, 6 plus 18 is 24. And that was 24 out of 80 times it landed on that. So now I have to figure out how many that would be out of 500. So again, we're going to cross multiply and divide. So I have 80x equals, here we go. So 500 times 24 gives me 1,000 or 12,000. Then I divide by 80 on both sides, and I get x equals 150. So I have 150 out of 500. So when comparing my experimental to my theoretical, they are really close this time. That means that the more times you do it, the more likely you are to get to that theoretical threshold or that theoretical value. All right, that's it for notes. Hopefully you can hear it this time, and I hope you have a great day.